Today, we are diving into a technology that is, and this is not an exaggeration, literally changing how we build and run our world. We're talking about digital twins. And forget about your basic 3D models. We're talking about creating living, breathing, data-driven copies of reality itself. I mean, just think about that for a second. What if you could stress test a brand new jet engine before a single piece of metal is forged? Or what if you could simulate a city's response to an earthquake to find the flaws in the plan before the ground ever starts to shake? That's the promise here, and it is absolutely massive. And look, this isn't some far-off sci-fi dream. The market for digital twins is projected to explode to over $73 billion by 2027. This isn't coming, it's already here, and it's making a huge impact right now. So let's get on the same page. What exactly is a digital twin? Well, at its core, it's a virtual model of something real, an object, a process, a whole system. But, and this is the key, it's not static. It is hooked up to the real thing with a constant stream of data from sensors, so it mirrors its physical counterpart in real time. It's a living digital copy. Okay, so now that we know what we're talking about, how in the world do you actually make one? It might sound incredibly complex, and it is, but we can actually break it down into a pretty straightforward 3-step pipeline. We're basically building a bridge from the physical world right into the digital one. And this is the roadmap. It's really that simple. First, you have to capture reality, get all that data. Then, you use that data to build the virtual world. And finally, you give that world a brain, a place to run simulations. So let's jump in, starting with step 1. First things first, capturing reality. This is where we go out and create a perfect digital photograph of the physical world. Think high-tech laser scanners, drones, and sophisticated cameras, all working together, collecting millions and millions of data points to stitch together a stunningly precise 3D copy. You know, what's truly mind-blowing is how this tech is becoming available to everyone. On the one hand, you've got the professional gear like a Leica scanner that'll set you back nearly $100,000 and is used for pinpoint accurate engineering. But on the other hand, you have an app like Polycam that lets you create amazing 3D scans with a phone that's already in your pocket. This democratization is a total game changer. And there are some real titans in this space. Leica Geosystems is basically the gold standard for that high-end hardware. Then you have software like Reality Capture and Pix4D, which do this incredible magic trick of turning a bunch of photos from a camera or a drone into a cohesive 3D model. And then you have companies like Navvis, who are making these wearable scanners so you can just walk through a building and map the entire thing. All right, so we've captured all that raw data. Now it's time for step 2, building the world. This is where all those millions of data points get assembled into a smart, interactive 3D environment. Think of it like taking a million puzzle pieces and snapping them together to create a living map. And here's the wild part. The very same software tools that are used to build the breathtaking worlds you see in video games or the CGI-heavy blockbusters, those are the exact same tools being used to build the industrial metaverse. These powerful game engines are the paintbrushes for this new reality. Let's look at the big 3 here. You have Epic Games' Unreal Engine 5, which is just the king of creating photorealistic interactive visuals. For architecture and construction, Autodesk Revit is the undisputed industry standard. And then you've got Blender, which is this incredibly powerful professional-grade tool that is completely free and open source. Just amazing. And that brings us to the final and, you could argue, most important step, finding a home for our digital twin. It needs a core platform to live on, an operating system that ties everything together and lets us run those incredibly complex simulations. This is where the real magic happens. And if you want to understand just how high the stakes are, just listen to this quote from NVIDIA. They believe the path to artificial general intelligence, that's AI that can reason and learn just like a human, runs directly through these simulators. So these aren't just virtual sandboxes, they are the training grounds for the next evolution of AI. And right now, 2 platforms are really leading the way. You've got NVIDIA's Omniverse, which is kind of like the operating system for a single complex digital twin, like one factory. It's the foundation. Then you have Cesium, which is more like the operating system for the entire planet. It provides a global 3D map so you can place that digital factory anywhere on a virtual Earth with perfect accuracy. So, we've walked through the how, we've captured reality, built the world, and gave it a place to run. Now, let's get to the really exciting part, the why. let's look at how this technology is already having a massive impact out there in the real world. First up, manufacturing. Companies are now building digital replicas of their entire factories. They can test production lines, predict when a machine is about to fail, and optimize workflows, all in the simulation. And the ultimate goal for some? The dark factory, a facility that's so perfectly automated it can literally run with the lights off. And this is not a theory. The electronics giant Foxconn used NVIDIA Omniverse to simulate their new factories, and the results are staggering. They reduced their setup time by 50%. By running every robot, every conveyor belt in the virtual world first, they ironed out all the kinks before spending a single dollar on construction. That's just a massive efficiency gain. But why stop at a factory? The next level is creating digital twins of entire cities. These cognitive cities are fed real-time data on everything you can imagine: traffic, power grids, weather, public transit. This allows city planners to make smarter, faster decisions and build better places for all of us to live. A perfect example is virtual Singapore, which is exactly what it sounds like: a detailed, living digital twin of the entire city-state. By using this model to optimize everything from bus routes to emergency response, they've boosted their overall urban efficiency by 20%. That's not just a number. That's less traffic, safer streets, and a better quality of life. You know, the funny thing is, the whole idea of a digital twin actually has its roots in aerospace. And today, it's more critical than ever. We're talking about designing next-gen aircraft and planning incredibly complex military operations, all within these hyper-realistic virtual models. The numbers here are just mind-boggling, and get this. Every single F-35 fighter jet has its own digital twin, which is constantly updated with data from over 300,000 sensors on the actual plane. This allows for a total shift from reactive to predictive maintenance. You're not fixing things after they break, you're fixing them before they break. It's a revolution in safety and readiness. But maybe the most important, the most profound application for all of this technology is in saving lives. By creating detailed simulations of our planet, from weather systems to geography, we can now predict the impact of natural disasters like floods or wildfires with a level of accuracy that was unimaginable just a few years ago. I mean, look at this. The Netherlands, a country that has literally been in a centuries-long battle against the sea, created a program called the Digital Delta. It's a massive digital twin of their entire water management system. And by using it, they have reduced the risk of flood damage by an incredible 40%. That is saving homes, businesses, and lives. So, all of this leaves us with a pretty profound question to chew on. As we get better and better at building these perfect digital copies of our world, these crystal balls that let us test and predict the future, we have to ask ourselves, what will we choose to change in the original? What problems will we decide to fix? That's the real power and the real responsibility of this revolution.